Hello maths fans! Dr. Tom Crawford here at the University of Oxford, and today I'm trying something completely different. This will be my first ever reaction video as I react to the YouTube sensation Animation vs. Math by Alan Becker. There's been a lot of chat about this video in the maths community and possibly even more in the YouTube maths community, and lots of you have even gotten in touch to ask my opinion on the video or if I have even watched the video, and my answer is I haven't. This is genuinely the first time I am going to sit down and watch any part of what I believe is a masterpiece. So I will be recording everything as it happens so you all get to experience firsthand my real reaction to the video. Let's get started. Okay, orange stick man. Love it already. And the number one. Okay. 1 does equal 1. Solid. Okay, 1 plus 1 is 2. 1 plus 1 plus 1 is 3. Is this going to test my mental arithmetic? Okay, we're up to 10. We're up to 10. All right. Ooh. He's had enough of the ones. I like it. If he's trying to get big numbers, this is sensible. Ooh, and a 20. Okay. Is this just gonna, it's just gonna count to infinity? Okay. All right, so we're on triple figures. We've got up to 100. He looks pretty tired. Now he's subtracting. Ooh, oh, this is a pause moment. So the -1 became e to the I pi. I like that. So that's Euler's identity. So I actually have a tattoo of this sort of here, but mine says e to the I pi plus 1 is equal to 0. So here they've obviously rearranged that a little bit and done e to the I pi is -1. And then his -1 is now turned into an e to the I pi. That's nice. Okay, that's the first bit of, like, I don't know, let's say advanced math that has come into this. Very cool. All right, where's this going next? Okay, E's running away, as it does. Who doesn't get annoyed when they lose their E, right? Neat. Oh, he's figured out multiplication. Interesting. Now we've got division. Okay. I'm gonna pause again. Interesting that we had plus and minus, various things going on there. And then we went to e to the I pi just to throw in complex numbers and irrational numbers, transcendental numbers in fact. And now we're bringing in multiplication and division. Okay, so we're only 2 and a bit minutes in out of 14, so I'm a little worried as to how advanced this might get, assuming this is just going to get more and more advanced. I genuinely have no idea. Okay. Ooh. Dividing by 0. That's not going to end well. Glad he figured that out and stopped that one early. Powers, okay. Indices coming in, nice, yep. Properties of powers, very good. Ooh, negative powers, lovely. Square roots, fractional powers. Irrational number, there's another one, root 2. Ah, okay, we have I. So after e to the I pi appeared, after Euler's identity, a good 2 and a bit minutes later, and we do now have square root of minus 1 is I. Okay, so we've got complex numbers. All right, wine time. Oh. Okay. I cubed, written as, it's actually minus I, but what they've done there is written it as I times e to the I pi, because you've, minus I is of course minus 1 times I, and then if you replace the minus 1 with e to the I pi. Okay, so Euler's identities come back, nice, okay. But powers of complex numbers, this is good, this is good. Like where this is going. 10 minutes to go. And nice to see the E has come back. It's not hiding anymore. Oh no, it's running away. I spoke too soon. Oh, little flash there of Euler's formula. So e to the I pi was very briefly replaced there by the, what was it, cos pi plus I sine pi. So that's generally true. Euler's formula says e to the I theta is equal to cos theta plus I sine theta. Very nice. Very blink and you'll miss it for that one. Nice little arc of a circle, love it. I can't believe I'm watching a sword fight between e to the I pi and an orange stickman. I'm having so much fun. Okay, e to the I pi by 4, very nice. I like how they introduced that and the angle, very clever. Okay, so there's a lot of nice sort of, pause again, there was a lot of nice sort of animation and playfulness, let's say, around the complex numbers there. So there were lots of arcs and circles being drawn, and that's hinting at this underlying behavior of e to the I pi. So because e to the I pi is actually equal to cos pi plus I sine pi, and more generally, e to the I theta is cos theta plus I sine theta, you can of course map that into the unit circle. So e to the I theta will actually describe any point on the unit circle as you vary theta, where 0 is going to be the x-axis, and then as theta increases, you can go all the way around for 2 pi. So that sort of fight scene between the two of them, it was really nice how the angle was changing as they were jumping, and the value was changing there in the e to the I theta. Very clever, like that a lot, very, very cool. Complex axis, yeah. And the real number line at perpendicular. Now he's drawn the circle. Now he's figured it out, like it. Stopping at 6 radians, because of course 2 pi, 3.28, 6.28-ish would be the full circle. Now he's drawing the radius. Yeah, there we go. Larger and larger plane. Okay. Increase the radius. Thing grows. Very good. Interesting how they're using theta r to represent the circle. Not quite sure about that. I'm not sure that's mathematically correct. The way we would normally represent the circle would be r e to the I theta. So as you vary the radius, exactly as in the video, it would change. But as you vary theta, it doesn't make sense to have theta times r. That's just an angle multiplied by a distance. I'm not actually sure what that even would look like, but I don't think it would be a circle, because your circle would be r e to the I theta. I guess I'll allow it. Ooh, we've got waves. Okay, so sine and cos as waves. Very nice. So the graph of sine and cos, both are wave-like. Okay, interesting. Plotting it in 2 dimensions, very good. He's back. Ooh, okay, that was a jump. So e to the I pi was just then replaced by its power series. So the exponential function e to the power x is equal to the infinite sum of x to the n divided by n factorial. And so, of course, if you have e to the I pi, you replace the x by I pi. So they've just thrown that one in out of absolutely nowhere. Although it's starting at n equals 2, technically it should start at n equals 0. That's interesting. I'm not quite sure why they've started that at n equals 2. Interesting. Yeah. I wonder what's going on there. But either way, that is bringing in the power series definition of the exponential function. Very nice. Okay, so it's like changing form during the battle. Very cool. I understand now. It's shooting the first few terms at the animated man. Okay, so you have this infinite long power series that gives you e to the I pi. You have all of these terms. So your first term is going to be 1, and it's going to be minus I pi, and then it's going to be plus I pi squared over 2 factorial, and you're going to carry on adding them. Very cool. No, sorry, it's going to be 1 plus I pi, yeah, and then it would be minus pi squared over 2, would be the third term. So it's firing those terms at him, which is why it's decreasing. Now I understand. So as it loses those terms, its value is changing, because now we're on 11. All right, got it. Sorry I missed that first time. That makes more sense. Because of course, the summation sign does look like a gun. Back to 0 again. Nice. There we go. Oh, new one. So it went to the power series, then it switched to Euler's Formula version, cos pi plus I sine pi. And now it's gone to the exponential definition of cos and sine. So cosine of x can be written as, remember this now, e to the ix plus e to the minus ix divided by 2. So that's what's happening here. So that kind of comes from Euler's, you take Euler's formula, e to the I theta, and add it to Euler's formula for e to the minus I theta, and then you use the symmetry properties of cos and sine to figure out what's going on. Some of them cancel, and you get this nice exponential form for sine and cosine. So it's throwing that one in out of nowhere. Okay, now where are we going next? It's multiplying. Has he just created a function gun? What's going on here? It would appear so. I'm never going to be able to look at functions the same again. And summation sign, they're all just guns. There's one badass orange stick, man. Oh, he's got the infinity sign. F of infinity. Causing all kinds of havoc. It sounds about right. Oh, so as he's shooting the function at infinity gun, never thought I'd say that sentence, it's hitting R and it's turning it into R2, R3. So I'm guessing each blast of infinity is adding a new dimension, it would appear here. Very clever, very clever. Okay. So we get to 4D, we get to R4, I'm gonna remember that. So we've got a combination of exponentials and series turning into some kind of transformer. Obviously. Oh, there's a log. Very cool, there's a log thrown in there. This is so entertaining. I want to watch a movie. Add 9i, shift up 9 spaces. Love it. So he's now translating himself through space. The waves of sine and cos, beautiful. Infinite series down. It's not looking good. Very clever that as he changes the radius, the width of the beam changes, because as you would change the radius, your sine and cosine would have a larger amplitude, which is what's given him a larger beam. That is very, very cool. Very cool. I'm such a nerd. Oh, we're in the inverted world. Oh dear. square roots of negative, apparently now breaking maths. Now they're trying to make friends. Beautiful. So if I've got this correctly, this idea of sort of flipping to the other dimension or inverting the black and white seems to be when you multiply e to the I pi by I. They appear to be going into another dimension. That's interesting. I suppose e to the I pi is a real number. It is -1. And when you multiply by the I, you are going to get -I. And you know, for a while, historically, complex numbers, square roots -1, square roots of negative numbers were thought to break maths. So it's a very cool interpretation. I think that's what's going on. My interpretation of it, at least. I to the power 4 is 1. Very good. Because if I squared is -1, that squared is the same as I to the 4. Gives you 1. Back to the unit circle, e to the I pi. Now we've got the series. Oh, gamma function. That's a new one right at the end. So the gamma function has just been thrown in. So the way I think about the gamma function, I actually have a whole video talking about the gamma function from quite a while ago, one of my first videos I made. But the way I think about the gamma function is it's an extension of the factorial function to non-integers. So if you have a number like 5 factorial, for example, and this is true for any n factorial, 5 factorial is 5 times 4 times 3 times 2 times 1 multiplied together, so that's going to give you 120. And if you have n factorial, that means n times n minus 1 times n minus 2 times n minus 3, and you go all the way down and you stop at 1, or 0. 0 factorial is 1. Now, the gamma function allows you to come up with a way of computing factorials for non-integers. So you can do pi factorial, and you can make sense of that through the gamma function. So it's kind of defined through an integral. Again, watch my video if you want to see a bit more about where that comes from. Didn't know that was going to appear. But they've thrown in now the gamma function in the definition there of your series. That's nice. Okay. And now we're creating all kinds of weird patterns. Sure. Infinite series of gamma functions, as you do. I knew the zeta function was coming. I knew the zeta function was coming. And delta and phi. Beautiful. Or maybe it's not the zeta function. I thought they were going to do it in all this chat about complex numbers. Oh, okay, we're calling that the end, so they're all friends now. Beautiful. I'm going to genuinely... That was fantastic. That was so entertaining. Well done, Alan Becker. I am going to literally click subscribe right now. I thought that was that good. All right, there you go, Alan. Subscribe. That was awesome. Loved it. Absolutely loved it. The animation is incredible. I'm assuming the rest of the channel probably has incredible animation, but I'd never seen it before. Hadn't heard of the channel, but that was something else. That was amazing. And all of that maths. I knew some hard maths was coming because that is what I'd seen people talking about on social media and various things. I really thought they were going to throw in the zeta function there at the end. They like teased it with the zeta symbol. but not necessarily the whole function. But no, that was awesome. That was amazing. So thank you everyone who suggested I should watch this. Thank you, Alan Becker, for making that. That was brilliant. And what a way to talk about and showcase our beautiful subject of mathematics. So I hope you enjoyed watching this. As I say, this was genuinely my real first ever watch through of this video. So you got my real first-hand reaction to watching this masterpiece, absolute masterpiece of mathematics and art and animation and everything great about YouTube. That was, honestly, I'm so happy just having watched that. But as I say, thanks for watching. I hope you enjoyed watching me reacting to this awesome video. I will, of course, be back very soon with more of my usual maths style content. If you have enjoyed this, please do subscribe to the channel. It's really helpful. And otherwise, keep having fun with maths, and I'll see you all very soon. Take care.